First, we have to learn some important facts on continuity. Facts on continuity. These are very important facts of continuity. After teaching all the facts from 1 to 5, I will tell some functions which are continuous and some functions which are not continuous and some of its properties. Now first we have to learn the fact, and I will tell you the fact 1, 2, 3, 4, 5 picturically. First, if f is continuous, learn from fact, listen here, from fact 1 to 5, everywhere I have underlined the words continuous, 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 and f is here continuous. On an interval AB, on an interval AB, on an interval AB, here exact at x is equal to a. So first fact is, if f is continuous at x is equal to a, f not equal to 0, then there exists, the symbol is there exists an open interval. This is open interval, a minus delta, a plus delta, fx has same sign as f. Look at here. Here is a function. Suppose this is a continuous function. So at this point the function is what? At this point the function is continuous, because I have drawn this picture without lifting my hand, means it is continuous. At this point the function is continuous, and this fa, this height, it is not equal to 0. Then there exists an interval. Suppose this is an interval. Interval means a small interval, and this length is delta. Then a minus delta, a plus delta. In this interval a minus delta, a plus delta, fx has same sign as fa. Means this is one fx, this is one fx, this is one fx. Every fx. Suppose this is fa. This fa is positive. Then this fx is positive. This is x, this fx, this height fx, and this fx. If it is x, then this fx is also what? Positive. If fa is negative, suppose this is a continuous graph. Suppose this is a continuous graph, and this is a. Now tell me what is fa? Naturally fa is negative. On this interval, a minus delta, a plus delta, every fx, every value of fx within this interval, a minus delta to a plus delta, fx is what? Fx is also negative. This is fx, this is fx, fx is also what? Negative. Then I will explain you why fa not equal to 0. If fa is equal to 0, then what will happen? Look at me. If fa is equal to 0, we cannot guarantee on this fact. Why? Look at here. Suppose this is a continuous function. This is a continuous function, and this fa is equal to 0. If fa is equal to 0, this is if the fact is fa not equal to 0. I am taking here fa is equal to 0. Let us see the problem. Then take an interval a minus delta and a plus delta. Then suppose this is fx. This fx what? This fx is what? Positive. And this fx, suppose this is a plus delta, and this fx is what? Negative. So now you have already learned the fact 1. You understand the fact 1. Next, fact 2. Fact 2 what? If f is continuous on an interval ab, here continuous at a point, here it is continuous on an interval, and fa into fb negative. What is that? Means this is Suppose this is A and this is B, and the function is continuous on this interval from A to B. The function, this is the diagram. This is the diagram, and the function is continuous on the interval AB. This is the closed interval. Means you have to include A and also B, then all points within AB. So that FA, what is FA? Suppose here FA. What is FA? FA is here FA positive. What is FB? Tell me what is FB? FB is what? FB is negative. Means it is y-axis. It is y-axis. Here the values are positive. Under this line the values are negative. So FA into FB. Suppose this is x-axis and this is your y-axis. And FA into FB is what? Negative. FA into FB is negative because one is positive and another one is negative. Then there exists one solution. Fx is equal to 0. Learn what is Fx. Fx means y. Y means Fx. Fx 0 means what? Fx 0 implies y is equal to 0. Here y, this line is y is equal to 0. So there exists a point where y is equal to 0 or Fx is equal to 0. This is the solution. Here Fx is equal to 0. Means if there exists a point above x-axis and there exists a point below x-axis and the curve is continuous, then we say there exists at least one solution. At least, very important line, at least one solution of Fx is equal to 0. Why it is at least more than, suppose this is the figure. This is Fa. Look at this figure. This is suppose Fa height. This is FB. It is B and this height is FB and this is Fa. Fa is what here? Fa is positive and FB is what? FB is negative. Here FB is negative. So Fa into FB. What is Fa into FB? Positive into negative. That is result is what? Negative. Fa into FB negative. Then the fact 2, there exists at least one point. So here how many points? 1 point, 2 points, 3 points are there. So if f is continuous on FB, Fa into FB less than 0, then there exists at least 1 point. Then there exists at least one solution of Fx is equal to 0. Fx is equal to 0. There is only at least one solution. Next. Fact 3. What is fact 3? Fact 3. If f is continuous on FB, k is any real number between f and FB, then there exists one solution of Fx is equal to a. Suppose here Fx, suppose this is the graph, here it is the function, here it is the function, this is A and this is B. F is continuous and the function is continuous on this interval AB. K is any solution, any real number between F and FB. Suppose it is FA. Suppose this value, you are telling this FA, suppose I am taking it, this is FA and this is FB. Suppose this is B and this value is height. Suppose this height is 7, this height is 3. Now within this height is 3, this height is suppose 7. Within this height you can get any number sorry, I am telling like this. My main note is this. Suppose this is any real number between f and then there exists at least one also. Now fact 3. Suppose this is a function. It is a continuous function. This height it is continuous on a. This is b. This function is continuous on what? A to b. F is continuous on a b. K is any real number between f and b. Suppose this height is k. K, the value of k lies between what to what? Fa and fb. This height is called fb. This height is called fa. And the value of k lies between this height and this height. Suppose this is 3, this is 8. So k is suppose k is equal to suppose 7. Now the question is, fact 3 is, if f is continuous on ab, k is any real number between f and b. Suppose k is 7, any real number 7 between f and ab, between 3 and 8. Then there exists at least one solution of fx is equal to k. What do you mean by fx is equal to k? Fx means you think always it is y. Y is equal to k. K means what? K is equal to 7. Means there, suppose I will draw a line y is equal to 7. This is 7, 8. So y is equal to 7 is a line parallel to x-axis and it touches this curve at a point. That is the fact 3. If f is continuous on this interval ab, k is any real number between f and fb, then there exists at least a point. There exists at least one solution of fx is equal to k, and this is your fx is equal to k. Fx is equal to k. Now this is fx is equal to k. If fb and k is a value between f and fb, then there exists at least one solution where fx is equal to k. That x, here is that x must belongs to ab. This x belongs to ab. Now fact 4. Fact 4 and fact 5. Fact 4 and 5. If f is continuous on ab, then it is also bounded on ab. That is, fx is less than equal to k for some k belongs to R. Suppose a function is continuous. It is continuous and continuous on the interval a, to b. Suppose this is a, then this is b. Then suppose this is a value x. The height is fx. This height is fa. This height is fb. If f is continuous on ab, then it is also bounded on ab. That is, each fx is less than equal to k. Suppose this is height is k. Now this height is suppose what? K. Now any height from this to this is most less than this height k. This is fact 4. Now fact 5. If a function f is continuous on ap and ap, then means every continuous function, this fact for every continuous function has an upper bound. This fact 5, every continuous function is bounded above and bounded below. Suppose this is a function, continuous function, and this is a, this is b, and all it is b. Suppose this is and this function is bounded by f and f. Here it is small a, here it is capital A. I can also draw another picture like this. Suppose this. Then this is my A and this is my B point. Suppose this is. here this continuous function is bounded by this, and all values of fx on this interval AB has upper bound m and lower bound small m. That is, every value of fx must less than capital M. This is this, and every fx must greater than small m. This is this, where m and m are some lies some x1 and x2 point in this interval AB. So this is fact 5. This is fact 5. Okay. Now I will teach you some problems. Now problem number 17. Prove that e to the power x minus 2 has a solution between 0 and 1. So first we have to take fx is equal to e to the power x minus 2. Then we have to put the value of f0. f0 e to the power 0 minus 2. It is 1 minus 2 is minus 1. What is f1? f1 is e to the power 1 minus 2. You know the value of e is 2.7. 2.7 minus 2. It is near equal to 0.7. So this one is negative and this one is positive. Now f0 into f1 is what? Is negative. Positive, negative into positive is what? Negative. This implies, if by fact, you see I have already taught you fact 1, 2, 3, 4, 5. Perhaps I think it is in fact 3. If fa into fb is negative, then there exists a solution between 0 and 1. This implies there exists, it is symbol of there exists a solution of fx. Fx means what? E to the power x minus 2. There exists a solution of e to the power x minus 2 is equal to 0 between 0 and 1. There exists a solution of e to the power x minus 2 between 0 and 1. Number 18. So that if x to the power 5 plus x plus 1 is equal to 0 for some values of x between minus 1 and 0. It has first we have to take fx is equal to x fifth plus x plus 1, then find value f minus 1. It is minus 1 power 5 plus minus 1 plus 1 means minus 1 plus 1 minus 1, which is equal to what? Negative. Then what is f0? f0 is 0 to the power 5 plus 0 plus 1 0 is equal to 1, which is equal to what? Which is equal to positive. f minus 1 into f0, the value is what? Negative into positive. Result is what? Negative. This implies if fi into fb is negative, then for some values of x between minus 1 and 0 there exists a solution. So solutions means it is 0. So fx, so x to the power 5 plus x to the power 5 plus x plus 1 is equal to 0. So this much x fifth plus x plus 1 has a solution for x belongs to minus 1 to 0. Minus 1 to 0. Minus 1 to 0. That is x fifth plus x plus 1 is equal to 0 for some values of x between minus 1 and 0. Or x belongs to minus 1. Next, number 19. Now number 19. To prove that this attains the value 2 for some value of x between 0 and 1. Suppose, very simple problem, very simple. And perhaps I think 3 marks question or 4 marks question will come on this problem. it is newly introduced to in both CBSE and CHSE syllabus. Fx is equal to e to the power 2 to the power x plus x square. Then tell me what is the value of f0? Is 2 to the power 0 plus 1 square is 2 to the power 1. 1 plus 1 is equal to 2. Now what is f1? f1 means 2 to the power 1 plus 1 square, that is what? 2 plus 1, it is 3. It is f0, it is 0 square. 2 to the power 0 plus 0 square, it is 1 plus 0 is equal to what? 1. Now 2 lies between what? Between 1 and 3. This implies 2 lies in between 1 3. This implies what is in place of 1 I can write f0 is less than 2 is less than what is 3. I can write it f1. So we can say 2 to the power, this is we can say that 2 to the power x plus x square attains the value 2. So 2 to the power x plus x square attains the value 2 for some x belongs to 0 1. Suppose the graph is like this. f0 you get what? The value is 1. Here suppose f0 you get 1. Suppose at f1 you get 3, like this. Suppose the graph is like this. Then you will get, suppose this height is 1 and this height is 3. Then in this interval, suppose this is 0 and this point is 1. At 0 you get height 1. At 1 you get the height 3. Now in the interval 0 to 1 you must get a height of 2 between 0 and 1. This is the concept of this problem number 19. Now number 20 is a very interesting one. Fx is equal to 1 or x belongs to q. Fx is equal to 0 or x does not belong to q. Before going to this problem, I am asking you find the value of f2. What is f2? Now f2 is 1 is these two belongs to rational number category. What is the value of rational number means which can be expressed in p by q form. Rational number in the form of p by q, which can be expressed in form of p by q. Suppose I am asking you what is f root 3, then it is what? 0. If a function is 1 for rational number, 0 for irrational number, so the function is not continuous anywhere. Let us consider a point A is equal to suppose 3. Now left hand limit of this limit x tends to 3 minus of fx is what? When x is slightly less than 3, then tell me it is rational or irrational. We cannot say whether it is rational or irrational. So it is undefined. The function is undefined. We cannot say fx is 0. We cannot say fx is 1 because we cannot determine what the number is, whether it is rational or it is irrational. Similarly, right hand limit x tends to 3 plus fx is what? Undefined. In both cases, both are undefined. So we cannot say, and the functional value is what? Functional value f3 is equal to 3 is the rational number, naturally it is 1. Since LHL, RHL, FV are not equal, In which place? At x is equal to 3. At a is equal to 3. At x is equal to 3, or you may take a is equal to 3. So, the function is discontinuous at a is equal to 3. At a is equal to 3. Similarly, the function is discontinuous at every point. This is point. And it is the only function which we cannot draw a graph, because rational, the value of the function 1 when it is rational, and the value of function is 0 when it is irrational. We cannot say in a number line which point is rational and which point is irrational, because we cannot know the exact value. Suppose 3, it is rational. Mere 3 we cannot say. Okay, that's the problem from 1 to 20.